All right, I'm going to try to make this pretty quick. This is one of the probably simpler things that we go through this year. Just the concept of what weight is in physics. So in physics, basically weight and mass are going to be two different things. And we just want to kind of clear those up today. So we're answering the questions of what is mass, answer the question of what is weight, and how do we calculate those things. So these should be, again, pretty easy for us to do. We'll give a few definitions, run through some examples, and wrap it up. So when we talk about mass, we're just talking about the amount of matter in an object. So like how much stuff there is in you. So you've been using mass throughout the year this year. We use the lowercase letter m for that, and we should be measuring that in kilograms. So again, kilograms something we usually don't use here in the United States. It's used throughout the world, and typically when people in the world are using kilograms, they really are talking about weight, um, because as long as we're on the Earth, and we all are, we can kind of use weight and mass interchangeably. They kind of mean the same thing. But again, sometimes science has a little bit more specific uh, vocabulary, and that's what I'm trying to clear up here with us today. So when we're talking about the mass, talking about how much matter is in things, how many atoms, how much would all that kind of add up to? Specifically, when we're talking about weight, we are talking about how much does gravity push down on that mass. And so weight, by definition in physics, is a force. If you get up onto to check your weight, you're getting up on a scale, and what the scale is registering is how much is it being pushed down. If someone stood above you and pushed down on you a little bit harder, the scale is going to go up. That's not because your mass is changing; it's because the scale is getting pressed harder. Likewise, if you kind of pushed up against in a different direction, that would make the scale register a little bit less. It's all about how much pressure, or how much, I shouldn't say pressure, how much push there is on the scale. So what we're looking at technically with weight is being a force, and that's what the capital F is, and the little bitty W is the force of weight. And so this is the force of an object due to gravity. Because it's a force, we're going to call it in newtons. So when we have a weight in physics, that weight is going to be measured not in kilograms, but the weight's going to be measured in newtons. So just kind of get this straight in your head. Weight and mass pretty much are the same thing every day in life, but not in here. And so that's what we got to kind of keep straight. Really, when we're calculating weight, it's just Newton's second law, which is F equals ma. But specifically, the force is the weight, and the acceleration is going to be 9.8, which is g here on Earth. So this formula is on your reference sheet, kind of as a reminder. So it was pretty simple for us to get the weight if we know the mass, because we're just going to multiply it times 9.8. So if we had a 100 kilogram object, its weight is going to be 980 newtons, because we would just do that 100 kilograms and multiply it times the acceleration of gravity, and that's going to be 9.8. Okay. If we were on the moon has a different acceleration. And so because the moon is so much smaller, we wouldn't use 9.8. We would use about 1/6 of that, which is 1.6. And so if we went to the moon, that same 100 kilogram object would have a much smaller weight of 160 newtons, because that 100 kilograms is going to be multiplied by 1.6 and not 9.8. So again, you would have the same mass on the moon, but you would have a different weight because gravity is going to change. So we'll keep in mind that weight can change from one place to another. Technically, on Earth, if you were like, probably on a really, really high mountain where there's slightly less gravitational pull, you would weigh a little bit less. That would be one of the easiest ways to lose weight on Earth is go to the top of Mount Everest. Um, Mass wouldn't change at all, though. So that doesn't actually mean that there's less of you. It just means there's less gravity pulling down on you. So we're going to run through a few examples. Again, we're either just going to be multiplying or dividing here. So these are pretty fast and pretty quick. So I'm going to go through them that way. If you need to stop, rewind, pause, whatever, do what you need to do. So if we're finding the weight of an 1,800 kilogram car and a 0.12 kilogram baseball, again, you got your formula right here. The weight is mass times gravity. Each of these I've given your mass. So all that we need to do is multiply times 9.8. So the 1,800 kilogram car, we multiply it by 9.8, and we get this many newtons, again, in the downward direction, which is generally which way it's going to be going. If we had the 0.12 kilogram baseball, same thing, multiply it times 9.8, and we get this many newtons down. So if we're trying to find weight, we just take mass, multiply it times 9.8 on Earth. If we're trying to solve for mass, a little bit more complicated because we have to rearrange our equation. Remember, could turn this into a triangle. If we turn this into a triangle, then the MA would be on the bottom. So if I'm solving for M, it's going to be force divided by acceleration, which in this case is going to be the weight divided by gravity. So if we're finding the mass of each of these, I would just need to divide them by 9.8 instead of multiply by 9.8. So 14 Newton box divided by 9.8, 680 Newton girl divided by 9.8. That tells us how many kilograms there are. Okay. If we were comparing the weight of an astronaut on the Earth and the Moon, again, use our formula again, change our acceleration on Earth, acceleration on the Moon. So 75 times 9.8 on the Earth, 75 times 1.6 on the Moon. So again, we get different weights on the Earth and the Moon, but we would not get different masses on the Earth and the Moon. And that, my friends, is basically it. So when we want to get the weight of things, we have to take into account what the gravitational pull is. If the gravity changes, then the weight changes. If the gravity changes, your mass, however, does not change.